this is the Unit 3 Fractions Part 2 review. If you're a Carlton kid, if you're a Dudley kid, it's the Chapter 5 review, Part number 3, Carlton. Same content. She goes by units. I go by chapters. Right as an improper fraction. Well, you simply multiply down. So 4 times 5 is 20. Plus the 3 would make it 23 fifths. Same thing here. Multiply down. 33. Oops. Now we're writing this as a mixed number. So this time we have to divide. 33 divided by 5. There's different ways to divide. This is an easy way for kids to do it. It does not work for decimals, but kids struggle with division, so this is an easy way to use repeated subtraction to find your answer. So let's put it in there 6 times would be 30. We have 3 left over. So our answer is 6 3 fifths. 6 3 fifths. And again, you can always check these. 6 times 5 is 30, plus 3 gives me that 33 fifths. 23 divided by 5, if I were to do this type of a process here, would give me 4 3 fifths. Okay, I can write the multiplicative inverse or reciprocal of a number. And you don't need to simplify here. So 3 times 5 would be 15, plus 4, this gives me 19 fifths. Now, a lot of kids think that that is the multiplicative inverse of the reciprocal, but it isn't. All I did was make that into an improper fraction. When I flip it, this is your reciprocal. Okay? 100, we make it into a fraction by putting it under, putting a 1 under it, so the reciprocal is 1 over 100. And again, look, you could multiply these across and you get 100 divided by 100. If you multiply across here, you get, let's see, I believe that's 5 times 19 is 96. No, let me see, 5 times 19. Not 96, 95. So if you were to multiply these straight across, you get 95 and 95. 95 divided by 95 is 1. That's why they call it the multiplicative inverse. It's whatever you can multiply that fraction by to get 1. All right, so 8 elevenths, just flip it. 11 eighths, that's an easy one. 24 fifths, we can just simplify it. 5 24ths. Or sorry, we just flip it. Again, you don't need to simplify it because then it's not going to work. All right. I can divide fractions without a calculator. All right, here's the big thing here. We're going to keep the first one. We're going to change the second one. We're going to flip the third one. So we'll keep it. We'll change the sign, and we'll flip it upside down. Oops, that's 8/3. All right, so now I'm going to make that just a little bit bigger. It's hard for me to read it. It's so small. All right, so now I can cross-reduce. Here I can divide by 4 once. Divide by 4 goes in there twice. I can divide by 3 here once. I can divide by 3 here. Goes in there 4 times. When I multiply across, 4 times 2, I just got 8 over 1 or 8. Okay, let's do the same thing here. We'll keep it. We'll change the sign. We'll flip it upside down. Okay, divide by 7. Divide by 7. Divide by 8. Divide by 8. So, we've got 1 times 2 on the top, which is 2. We've got 1 times 2 on the bottom, which is 2. 2 divided by 2 is simply 1. All right, let's try this one. We'll keep it. We'll change the sign, and we'll flip it. And once again, we can cross-reduce both ways. Divide by 5 here, it's 5. Divide by 5 here, it's 7. Divide by 3 here, it's 1. Divide by 3 here, it's 7. 7 times 7 is 49. 5 times 1 is 5. So now we have 49 divided by 5. Well, it won't go in there 10 times, but it'll go in there 9 times, which is 45. And you have 4 left over, so it's 9 4 fifths. I can double check that. 9 times 5 is 45, plus 4 will give me that 49 fifths again. Okay, I can divide mixed numbers without using a calculator. Same thing, keep, change, flip. However, you have to make them into improper fractions, so let's do that. 3 times 5 is 15 plus 1 gives me 16 fifths. We're still dividing. 2 times 2 is 4 plus 1 is 5 halves. Okay, so now we can do the keep, change, flip. We'll keep it, we'll change the sign, and we'll flip it. Okay, keep, change, flip. 16 times 2 is 32. 5 times 5 is 25. So we have to take 32 divided by 25. Well, it only goes in there one time, and there's 7 25ths left over. So 1 and 7 25ths. All right, same thing here. This one's already a fraction, so we're just going to leave that, 2/3. Leave that division because we still have to make this into an improper fraction. This is where kids get in trouble. So 1 times 6 is 6 plus 1. This is 7 6. So we'll keep it. Now we'll change it, and now we'll flip it. 6 comes up at the top, and the 7 goes in the bottom. 7 6, 6 sevenths, 5 halves, 2 fifths. You just kind of go back and check each problem to see if I did it correctly. 14 16ths, 16 14ths, 3 35ths, 35 thirds, 3 eighths, 8 thirds. You can see how we keep flipping and checking. All right, so we can divide by 3 here, which is 1. We can divide by 3 here, which is 2. We can't do anything with 2 and 7, so let's just multiply across. 2 times 2 is 4. 1 times 7 is 7. That's in simplest form. We're done. All right, let's try this one here. 5 and 1 7 divided by 2 and 1 7. Let's just do the make them into impropers. 5 times 7 is 35, plus this one guy here makes this 36 sevenths. 5 times 7, 35, and 1, 36. 2 times 7 is 14, plus 1 make 15 sevenths. We're still dividing there. Okay, all we do is change them, rename them. So let's keep it, change it, flip it. All right, well, we can divide by 7 here, it's 1. We can divide by 7 here, it's 1. These two, we can divide both by 3. So 15 divided by 3 is 5. 36 divided by 3 is actually 12. So when we multiply across, we have 12 on the top, 12 times 1, and then 1 times 5 on the bottom, which is 5. 12 fifths, well, as you probably know, that 5 goes into 12 2 times, and there are 2 fifths left over. Quite get that, I'll do it here. 12 divided by 5, 2 times would be 10, and when you subtract, you have 2 left over. There's your 2 and 2 fifths. All right, down to the bottom of the page, gets all the equations using the multiplicative inverse or the reciprocal. So I'm just going to take and rewrite this down here. Get it away from that 13. Okay, well, the reciprocal of 2/3 is 3 halves. So the way we get rid of this dividing by 2/3 is to multiply by the reciprocal. Remember how I told you that's going to equal 1 when you multiply by the reciprocal? But you got to do it on both sides. So you got to multiply this by 3 halves. Well, these dudes just cross off. I mean, if you don't want to cross them off, you could do 3 times 2, which is 6, and 2 times 3, which is 6. Then you have 6 over 6. 6 divided by 6 is just 1. But we can just cross those off and simplify it and say that that's m. If it makes you feel all warm and fuzzy inside, you can put a 1 in front of it because it's 1m, but we don't do that. And then we just multiply these fractions on this side. Well, I can divide by 2 here. That's 1. I can divide by 2 here. It's 6. So when we multiply 6 times 3, we just get 18 over 1, or 18. Now, let's see if it makes sense. 2/3 of 18 is equal to 12. Yeah, that makes sense. 1/3 of 18 would be 6. 2/3 would be 12. 3/3, or the whole 18, would be 18. All right, let's try this one. This one's a little simpler. W divided by 11 equals 3. I think it's simpler. Well, this is something divided by 11. It's really the same as you could think of it as putting a 1 in front of it if you wanted to. But the idea is that instead of dividing by 11, the way we get rid of that is we multiply by 11. So I'm going to multiply by 11 here on both sides. Set this up with some railroad tracks. These 11s cross off. You just have W left. 3 times 11 is 33. An easy one to substitute your answer. Just put it in there. 33 divided by 11 is 3. Absolutely. All right, so on this one here, we have 4/5 equals 4/7 B. Now, this is a little more tricky. Well, again, we've got to get rid of this fraction, this 4 divided by 7B. We don't care what that is. We want to know what a whole B is. So I'm going to multiply the whole thing by the reciprocal of 4/7, which is 7/4. This is going to cross out. It's going to leave me with a whole B here. But I have to do the same thing on this side. Okay. Now, we can look diagonally here when multiplying and see that I can cross those out. And I end up with 7, if I multiply across, end up with 7/5. Well, that's an improper fraction, so we have to call that 1 whole and 2/5 is equal to B. That's a little bit upper level, but if you follow the steps, it works out just fine. Okay, thanks. Go to page 2 here. Okay, so now we have some word problems here. Let's take a look and see what we got going. Liz collected 3/4 of a bag of leaves. Ibrahim collected 12 times as many leaves. How many leaves did Ibrahim collect? Well, it would be 3/4. Ibrahim collected 12 times his money, so we'd have to take whatever Liz had and multiply it by 12. Now, I know that sounds weird, but let's just say that she collected 6 bags, and he collected 12 times that much. You just do 6 times 12, right? So if you're going to just do 6 times 12 in that case, you know, if Liz only collects 3/4 of a bag, then you have to still multiply that by 12. It's the same thing. It's just easier to understand when it's a whole number. So put a 1 underneath the 12 and just multiply across, or I love to cross reduce. Right here. 4 divided by 4 is 1. 12 divided by 4 is 3. Now when I multiply across, I have 3 times 3 on top, which is 9. I have 1 times 1 on the bottom. It's just 9 bags. All right. Elsa is remodeling her bathroom floor. She's going to use a tile that is 4/9 a foot long. If her bathroom is 7 1/3 feet long, how many will she need to cover to first cover the length of the bathroom? So they're talking about the bathroom here, and they're just kind of talking about this one row here. So if the tile is 4/9 of a foot, you're looking at it like this. Each of these would be 4/9. So if her bathroom is 7 1/3 feet long, if this entire distance here is 7 1/3, we're going to have to take and divide to find the answer to that. So we will take that 7 1/3. Oops, let me change that around. That is 7 1/3. And we are going to divide that by 4/9. I'll write that a little closer. So here's our problem here. All right, let's make this into an improper fraction. 7 times 3 is 21, plus that makes that 22/3. And we're dividing that by 4/9. Okay, well, we have to do the keep, change, flip yet, so I'm going to get this out of the way here. Maybe I'll just pop in a sticky note, and I'll just work down so you can see that. Probably be a better idea. So we can do the keep, change, flip. So we'll keep this one, 22/3. We are going to flip the sign, keep it, we'll change it, and then we'll flip this to 9/4. And we'll see that we can divide by 3 here, and divide by 3 here, do some cross reducing. Here we can divide by 2. 22 divided by 2 is 11. And 4 divided by 2 is 2. So when we multiply that out, we've got, on the top we have 33, and at the bottom we have 2. So we have 33 halves. Well, 33 divided by 2. That's going to go in there 16 times. 16 times 2 is 32. There's one left over, so it's 16 and 1/2. So 16 and 1/2. And I believe that's going to be tiles. Let's just take a look at that again. So she's going to need 16.5 tiles in this first row to cover that. All right. Okay, so we're just going to move that guy up now. Dina added 5/6 of a bag of soil to her garden. Sorry, I like to write while I read. Her neighbor Natasha added 11/8 bags of soil to her garden. How much more soil did Natasha add than Dina? So we have 5/6 and we have 11/8. Well, how much more did Natasha? This is telling us we're going to need to subtract. So we have this 11/8 and we need to subtract 5/6. Well, this kind of a problem here, we have to have a common denominator when we're going to subtract. So we can make this a common denominator between 6 and 8 by going to 24. So if I take this times 3, I'll get to 24. If I take this times 4, I'll get to 24. So 11/8, this becomes 24 on the bottom. And if I multiply by 3 on the bottom, I got to multiply by 3 on the top. So this becomes 33 24s, and we're subtracting. Again, we know that 6 times 4 is 24. But we also have to multiply that top by 4, which makes it 20. So when you subtract out 33 minus 20 on the top, we've got 13 24s more. So that's really, it's 13 24s bag of soil. So a little more than half a bag of soil more. Okay? And a warehouse has 12 8/10 meters of tape in one area of the building. 12 8/10 meters of tape in one area of the building, and 8 3/5 meters of tape in another. How much tape does the building have in all? Well, this looks like an addition problem. There's 12 8/10 in one part, and 8 3/5 in another part. So we have to get these in, make these, you have to have a common denominator. And luckily, we could change this one here. We could divide this by 2 and get this to fifths. Or we can multiply this by 2 and get this 2/10. I think it's easier to work with smaller numbers. So I'm going to divide this. I'm going to rewrite this. I'm going to divide this by 2 and call this 12 4/5. We're going to add that to the 8 3/5. Now, if you want to, you can flip these into improper fractions. Improper fractions always work. But I'm going to go Sal Khan from Khan Academy. Here's the way he would solve it. He'd say, well, that's really the same as 12 plus 8 plus 4/5 plus 3/5. And our commutative property that we studied in Chapter 1 tells us that we can do that too. So here, we got 20. Here, we have 7/5. Well, 7/5 is really 1 2/5. I mean, I could take out 5/5 here. Here's a whole. If I take out 5/5, 7 minus 5, I still have 2/5 left. So I'm going to call that 20 plus the 1 plus the 2/5, which is really the same as 21 2/5. And you can kind of see it here too. Here's your 20. Here's your 7. Okay. Here's the vocabulary words, and I just wrote these out ahead of time so I could save some time. Proper fraction is just a fraction where the numerator is smaller than the denominator. The product is the answer to a multiplication question, like 2 times 3. 6 is the product. A mixed number is a number that has a whole number and a fraction attached. The numerator, as I've said, is up top. The denominator is down at the bottom. The answer to a division question is called the quotient. The denominator, we talked about. The sum is the answer to an addition problem. We've been doing that one since first grade. Here's your sum. The difference is the answer to a subtraction question. Here's your difference, the difference between 2 and 1. Proper fraction is a fraction where the numerator, and that one is on there twice, the numerator is smaller than the denominator. The 15/8 would be an improper fraction. I'm thinking that's probably what we wanted here is improper. So let's just add improper down at the bottom. Improper fraction would be, the 3/2, where the numerator is bigger than the denominator. Compatible numbers are numbers like 7 and 3, 9 and 1, 11 and 9, 33 and 7. 99 and 1, 66 and 4. These numbers that go together easily to make a multiple of 10 or 100. And then reasonable answer and estimate. This is what we're trying to get kids to do. These are just close answers, an approximation, to get you in the ballpark. And you do that so that when you actually perform an operation like multiplication, division, addition, or subtraction, you can see if your answer is, if the answer that you come up with when you solve is close to your estimate or reasonable answer. All right, thanks for listening.